In these three problems, number 1, 3, and 5, we are asked to discuss the continuity of each one of these functions at a particular point. It's probably a good idea to start by just reflecting back on these three conditions of continuity. For a function to be continuous at some point, like at 1, or at 3, or at 2, these three conditions all have to be satisfied. If one condition fails, then we can conclude that the function is not continuous at that particular point. So let's start here in number 1. So in number 1, let's look at this first continuity condition. Is f of a defined? All right, that's the first condition. Is f of a defined? And a, in our case, is 1. So we're going to see if we can put 1 back into our function and actually compute. So I computed this at this function at 1, and I got 0, so we can conclude that f of a is defined. So condition 1 is satisfied. I'll just make note of that here. So because f of a is defined, we'll say condition 1 is satisfied, and now we'll move on to condition 2 and see if condition 2 is satisfied. Now condition 2 says the limit exists. So let's look at our function and see if the limit exists. So let's take the limit as x approaches 1, right, because that's the value at which we're interested. So f of 1 of f of x, well, f of x in our case is 3x squared minus 7x plus 4, and because this is a polynomial function, we have a rule, right, that states that the limit is just, we can substitute 3 times 1 squared minus 7 times 1 plus 4, which we know to be 0. So condition 2 is satisfied. The limit does exist at 1. And I'll make note of that here. So condition 1 is satisfied. Condition 2 is satisfied. Let's move on to condition 3 and see if the limit as x approaches 1 in our case is equal to f of 1. So look at condition 3. It says the limit of f of x as x approaches a, and a in our case is the 1. So let's just take a look at that. It says that the limit as x approaches 1 of f of x, that has to equal f of 1. And in our case, the limit is, we just found that, that's equal to 0, and that's equal to f of 1. We found that to be 0, so that's checks. So condition 3 is satisfied. So we're going to say, I'll just write it here to make it a point, condition 3 is satisfied. So since the first condition is satisfied, the second is satisfied, and the third, all three conditions are satisfied. So we can state now that this function here, back in number 1, is continuous at this point. So let's make a statement here. Let's say that because all three continuity conditions are satisfied, we conclude that f of x is continuous. Now, our job was to do this. Our job was to discuss the continuity of this function. We ran through all three conditions. They were all three satisfied. So now we have to make a statement. And we'll state that we're stating that it's continuous, and here's why, right? Because all three conditions are satisfied. So we'll say that up front. Because of this, then this. Let's move on to problem 3 here. Let's look at condition 1. And condition 1, that says f of a is defined. So if we put in 3, is this defined? So let's try this. Let's say f of 3 is equal to 3 squared minus 5 times 3 plus 6 over 3 minus 2. And this computes to 0. So condition 1 is satisfied. So let's move on to condition 2. Now condition 2, we want to take a look at the limit as x approaches 3, right, as 3. That's the number that we're interested in, as 3, of f of x. So what we want to do is see what happens here. X squared minus 5x plus 6 over x minus 2. And because this function is a rational function, we can use that property we had for rational functions, meaning we can just take the limit of the numerator and the limit of the denominator. So if we do that, we're going to put 3 in. Just substitute 3 in. We'll get 0 over 1, right? If you put in 3, you get 3 squared, 9, minus 15, negative 6, plus 6 is 0, over 1, and that just turns out to be 0. So the limit does exist. It's equal to 0. So condition 2 is satisfied. So I'll just make a note of that here. Since the limit does exist, condition 2 is satisfied. Let's move on to condition 3. In condition 3 here, we want to know, does the limit as x approaches 3 of f of x equal f of 3? Well, it does, right? Because this is true since the limit was 0, and that's equal to f of 3, which was 0. So condition 3 is satisfied. Now let's just run through what we've done. We analyzed condition 1, it's satisfied. We looked at condition 2, it's satisfied. We looked at condition 3, it's satisfied. So because all three conditions are satisfied, this function here is continuous at 3. Let's look at this number 5. Now number 5, if you look at this, looks very much like number 3. But number 3 was to try this. At number 3, we wanted our function at what? At x equals 3. This one, we want to talk about the continuity at 2. So if we look at our continuity conditions, let's get those. And here they are. So the first condition is that f of a has to be defined. Now our a in this case is 2. And back in problem 3, it was at 3. But now we're at 2. So let's take a look at the first condition. The first condition, what about f of 2? Well, if we put in 2, we're going to get 2 squared minus 5 times 2 plus 6 over 2 minus 2. Oh, you see a problem already, right? What's that denominator? That's 0. Right? This is indeterminate. I'll just abbreviate indeterminate, and that implies that f of 2 is not defined. So now we're going to say this. Because continuity condition 1 fails, right? Condition 1 was f of a being defined, and f of 2 was not defined. So we will say, because continuity condition 1 fails, we conclude that f of x is not continuous at x equals 2. It's not good enough just to say f of x is not continuous. We have to say why, and we're saying that here. Because condition 1 fails, f of x is not continuous at that particular point. Let's move on here to number 7. So let's take a look at these conditions of continuity. And as if by magic, I can just bring them right back. So here's our three conditions. Let's start here with number 1. Number 1 says f of a must be defined. If this function is going to be continuous, it has to be defined at 1. So what happens here in condition 1 if we try to put in 1? Well, look at this. What do we use here? If x is less than 1, we use this piece of the function. If x is greater than 1, we use this piece of the function. There's nothing here that tells us what to do exactly at 1. So f of 1, in this case, is not defined. And we can say, because condition 1 fails, this function, how about fn for function? This function, f of x, is not continuous at x equals 1. So again, we're going to say why. Because the first condition fails, it's not continuous. We don't want to just say it's not continuous. We want to say why. And why? Because condition 1 fails.